before this decade is out, of landing a man on the moon and returning him safely to the Earth.
So hello everyone, I said I was going to do some playthroughs around leaving Earth, but before we start I would like to show you what kind of a location hog this actually is. This is the setup for the base game only. So here you've got all of the cards that you will be using. I've set up as the French space agency. Basically you get up to 6 spacecraft, and I'm told you can use as many as you like, but you know, they think that 6 are probably sufficient. Here you've got your outcome cards. I don't know why they have different backs, so maybe it's, I don't know if these are from the expansion, it doesn't say, but it doesn't really matter, because as long as you make sure that each of your research and development programs only has one back on its outcome cards, you won't be able to distinguish between them. Here you've got your supply card, here we've got supplies that you can buy, times 5, times 1, times 5, times 1. Venus samples, Phobos samples, Moon samples, Mars samples, Mercury samples, which we're not playing with because I'm not going to do the Mercury expansion thing, and Ceres samples. Up here we've got the possible research and development things that I can engage in: surveying, Juno rockets, Atlas rockets, Soyuz, Saturn, ion thrusters, life support, re-entry, landing, and rendezvous. These are the things that come with the base game. I don't know if the expansions provide any more of these, but that's what we're concentrating on at the moment. Here we've got the actual cards that you will be using. You've got the Juno rocket, the Atlas rocket, the Soyuz, the Aldrin capsule, the probe, the Eagle capsule, the Vostok capsule, the ion thrusters, the Saturn rocket, and up there the Apollo capsules. We've got our different types of astronauts. We've got the medics. We've got the pilots. I don't know if you can see this. The medic has a red cross in the top right-hand corner. The pilot has a little steering wheel, and this is the mechanic, and he's got a little wrench. Over here we've got the cheat sheet, which helps you to calculate the payload, and for each of these different types of rockets really, and the difficulty levels. Down here you've got the time scale. We start in 1956, going up to 1986. Of course, you flip this one over to reach 1966. And then you have the actual orbit, the actual sky above Earth. So here we've got Earth. Solar radiation I just put here, you can put it anywhere, it doesn't really matter. Suborbital flight of Earth, and these are all unexplored. When it says unexplored over here, for example, or with Mars, and up there with Mercury and Venus and Ceres, it means that there are different cards that have the same back, namely Venus, unexplored, and as you turn them over, when you, for example, land on Venus and do some exploration, you will see what Venus is like on this playthrough. And all of the others only exist once, so I think there's only one lunar flyby card. There's only one Phobos, I believe. I'm not sure if I've got more than one Phobos card. I think I might have, but there's only one Mars flyby card. Mercury, of course, has 2, or at least 2 Mercury cards. And then we've got the inner planet transfers. So basically, from here you go down to Earth orbit. From here you can go over here to Mars, and you can go to Venus. Flyby Venus orbit is up here, and Ceres is up there. And what we're going to do is, I'm now going to put down the camera and put it on a tripod so that the shaking stops. And what we will now do is we will go through this book, which is the handbook, the introduction, and then we will go through the basics of rocketry. So this video will kind of try and explain how the rules teach you how to play the game, because quite often people complain about rule books and it's not even quite clear why they are complaining. Now, this rule book is exceptional in the way it's been done, because the rule book essentially assumes that you know nothing about rocketry, and I, for one, can say that I know nothing about rocketry. I'm the Jon Snow of rocketeers, and they are trying to explain to you how to actually play the game from a more, I guess, scientific point of view, because this is maybe not so much a game as it is a scientific exploration simulation. I think this is probably more what it's like, and a lot of people have said they feel it's like a puzzle. And I've said in another video that I've learned by now that when gamers say something is a puzzle, it seems to have a very negative connotation for them. But I'm a puzzler, and I admit to being a puzzler, so I'm actually completely happy about this. Okay, so what we've got here is a little spaceship. It doesn't matter which one you choose, you have different ones, but this is the one I'm choosing, and I'm gonna see, okay, the black doesn't really come out on camera that well. Let's see if maybe red shows up a little better. Yeah, the red is probably a little better. Okay, so we're going to use the red rocket for the moment. So, and we will read from the good book. A spacecraft begins with a spacecraft card. And it actually has the same symbol as the little wooden miniature that I just showed you. We're going to place it here for the time being. Each of these cards has a corresponding spacecraft token. Find a spacecraft card, blah, blah, blah. We've done this. And now find a probe. And we're going to just pick the cards. The probe cards, etc. are all the same. They don't have a special back. It doesn't really, it just says damaged. So basically there is no difference. If you take this probe, all of these probes are identical. So we're going to take this probe and we're going to put it on this spacecraft card. And they also tell us to get 3 Juno rockets. However, they tell us to only place 1 Juno rocket on top of the spacecraft card. So how this works is essentially that the spacecraft card tells you what your spacecraft is made up of. The little token tells you where your spacecraft is at. Location cards, for example here lunar orbit, represent places a spacecraft can go. Find the locations lunar orbit and moon, then place them on the table, which we've done. Well, basically I'm playing on my living room floor because I need space. Then the demonstration spacecraft begins in orbit around the moon. So we're going to place it here. It's in lunar orbit. A spacecraft card shows what a craft is made of, while a spacecraft token shows where the craft is. Mass and thrust. A component's mass is shown in the upper left-hand corner. So I'm just going to show you the Juno card, and you can see this little scale symbol and the 1 above it. It means that this Juno weighs 1 unit. So I don't know if this is ton, probably megatons. I don't know how heavy this is, but it's got a unit weight of 1. Okay. Now the probe itself also weighs something. Of course, it has a weight of 1 as well. So this token represents a spacecraft that has 2 units of weight. Okay. So not only does it show us how heavy it is, but more importantly, it shows how hard it is to move. Propelling a spacecraft is like pushing a car. A light car is easy to get rolling, while a heavy car takes much more effort. Juno rockets and probes each have a mass of 1, therefore the spacecraft sitting in front of you has a mass of 2, 1 from the probe and 1 from the Juno rocket. Rockets and thrusters provide thrust. This is demonstrated by this little arrow down here, showing upwards and then a figure beyond it, below it. So this is number 4, so this provides a thrust of 4. So this shows how hard the component can push, propelling a spacecraft from one location to another. Maneuvering. Location cards have maneuvers showing where a spacecraft can go from this location. Now, lunar orbit has 2 places where you can go to from. Earth orbit, over here, and moon, down here. So you can either, once you're in lunar orbit, you can do one of 2 things. You can either go down to the moon, or you can go back to Earth orbit. You cannot, although they're in close proximity, go to Venus flyby or to lunar flyby. You can't because there is no link between here and here. However, if you are in lunar flyby, you do have the possibility of either going to the moon, to Earth orbit, or to lunar orbit. So this works, but this doesn't. From lunar orbit, there are only 2 places you can go. We discussed this. The difficulty of a maneuver is the amount of thrust required to propel each unit of mass. In other words, to propel a mass of one from lunar orbit to the moon requires a thrust of 2. To propel the same mass to Earth orbit would require a thrust of 3, because it says 3 here and 2 here. So basically, I suppose this represents the fact that the moon has gravity. And if you want to leave orbit and go to Earth orbit, you have to overcome some of this gravity because the moon will pull you back. And of course, if you want to go towards the gravity, it will become a little easier. You need less push because you have somebody pulling you. If the spacecraft were more massive, it would require more thrust. So thrust required equals mass times difficulty. Our spacecraft has a mass of 2. And it has a difficulty of 2, so 2 times 2 is 4. So in order for us to move this particular spacecraft from lunar orbit to the moon, we would need 4 thrust. Now, luckily, our Juno rocket has 4 thrust. So if we wanted to go the other way towards Earth orbit, we would need 2 times 3, which equals 6. And our Juno rocket at the moment only has 4 thrust, so we couldn't even make it. So what we do is we basically decide to go to the moon because that's the only place where we can go. We could of course just keep circling, but then nothing happens. We're just, orbiting the moon and nothing happens. So once we do this, of course we have, if you like, expended the Juno rocket, because we've used it and it's a one-time use only. So this card goes away. And now we have our spacecraft and it only consists of the probe. So the probe is now on the moon. It's a little bit like the one that the Chinese put on the dark side of the moon. It's simply just sitting there. It's on its own, it's cold out there, it's dark out there. And that's all it can do. Why? Because it has no thrust. It's just a probe. So now the question is, if I wanted to go there and then come back, what would I need to do? Now, in order to go from the moon to lunar orbit, I have to overcome a difficulty of 2. So again, since my probe has a weight of 1, I would need 2 thrust. However, I have no rockets. Sitting here, I needed 4 thrust to go down here with a Juno rocket and a probe. We see that the probe goes away. We see that the rocket goes away, so the probe is on its own. In order for it to go back, it would have had to have brought its additional rocket with it to begin with. However, this would have increased its weight. So if we say we want our lunar lander to go back into lunar orbit. So we have our probe, and I'm just going to remove it from the spacecraft card for a minute. So it's the probe that's sitting here. To get back up here, we need a thrust of 2. At the moment, our thrust is 0. So we're going to add a Juno rocket to it because we know this provides a thrust of 4. So if this was what we had deposited on the moon, a probe and a Juno rocket, This would be enough to lift off again and go back to lunar orbit. However, we started out here. So in order to get all of these two cards, or these two components I should say, onto the moon, we needed to have them when we were here in the first place. Plus we also needed one Juno rocket to go down to the moon. So we're going to add this one Juno rocket that we need to go down to the moon to our spacecraft. So now we suddenly have a payload of 3 while we're still in lunar orbit. And we have a difficulty of 2. So 3 times 2 is actually 6. However, the one Juno rocket that we have to bring us down and have dedicated to the moon landing only has a thrust of 4. So we need more thrust to go down with the probe and the Juno rocket that we need to lift off. So let's just say the stuff that we need to land on the moon and to bring back the probe, we will put sideways. The stuff that the rocket we're going to take to use to take us to the moon, we're going to put this way up. Still not enough, only 4 thrust, but we have a difficulty of 6. So what we're going to do is we're going to add another Juno rocket. Now we have a total payload of 4. The Juno rocket to bring us back from the moon, the probe itself, one of the Juno rockets we need to land, and the second one we also need to land. And this means we have a payload of 4 times 8. Times 2, because that's the difficulty, equals 8. So that is enough to do the following thing. Move down. We need a thrust of 8 at this stage to do this. So these 2 get expended. And then, in order to get back up again, we fire off this rocket, move back up again, and our little probe is now again in Earth orbit. But again, it's just sitting there. It cannot do anything else. It can't go back to Luna, or it can't go back to Earth. It can't go back to the moon. It can't go back to Earth orbit. It can't go back to the moon. It's just now again circling the moon, or orbiting the moon, I should say. So this is essentially how this game works. You have to find out what your mission is, and in this case our mission was send a probe to the moon and bring it back up again. And in order to be able to do this from lunar orbit, this is what you need to, these are the calculations you need to perform. Usually, of course, you don't just start in orbit, you would start on Earth. And there it gets really interesting, because what you need to do is you need to first of all lift off Earth, which has a difficulty of 3 to get to suborbital flight. Then you have Earth orbit. From Earth orbit to from suborbital flight to Earth, you have another 5 difficulty. Then another 3 to get to lunar orbit, and then another 2 to get down here, and then another 2 to get back up, and then another 3, and you know, you see where I'm going with this. And you have to basically start planning this from the very beginning to see, if I want to do this, and I have my probe and it has a weight of 1. Going into suborbital is going to take me 1 times 3, so I need 3 thrust. A Juno rocket provides 4, however it also weighs 1, so now we're looking at providing 6 thrust just to get here. So we need another Juno rocket. However, now we're weighing 3 times 3 is already 9. So this one isn't enough, so we have to add 1 more. 4 times 3 is 12. So these 3 Juno rockets will be able to get us into suborbital flight, but that's as far as we can go. That's all we can do. So at this stage you can see you would like to start buying different types of rockets. So for example, an Atlas rocket has a weight of 4 but a thrust of 27. So, you know, so one Atlas rocket could lift one probe easily for 5, for 15 into here and still have 12 thrust to spare. So you could put a lot more weight on this one to make it work. However, of course, if you were to have a spaceship that is a probe and an Atlas rocket and you go from Earth to suborbital flight, again, the Atlas rocket would be spent. So that's it, you're just sitting there. Again, you wasted essentially 15 points of thrust. So you do want to put a lot higher payload on this one to use it, to justify using this. So essentially that's how the game works in a nutshell. So basically, once you have done this, once you have gone through these couple of pages, you have understood the concept of maneuvering, and that is really the core concept. It actually says here, maneuvering is the core of leaving Earth. Before moving on to the next chapter, be sure that you have a firm grasp on the concepts of mass, thrust, and maneuver difficulty. Understanding how to expend rockets to perform maneuvers. During the actual game, several other problems can affect maneuvering: exploding rockets, dangerous environments, etc. These are ignored in the demonstration. See maneuvering on page 23. So this is essentially the way they explain the game to you, and it takes them 1, 2, 3, 4, 5 pages with illustrations. And I think that this is probably, this has to be the most concise way of explaining a game that I've ever seen. So what we're now going to do is we're now going to close this video, and next up we're going to face the setup. Well, actually we will probably do the setup just now because I've already essentially set it up, but we can go through this as well. Follow the directions below to set up the game. The exact layout of the table is not important as long as the cards are visible to all players. Well, we're playing on our own, and yeah, I mean, it is true, you just need to be able to see your own. So I'm going to put this here, probe up there. We chose a space agency. I took the French. And then we take all of the spacecraft cards and matching spacecraft tokens. I've done that. I will replace all of the black ones with the orange ones. And again, I would like to point out that the way the rules are written, it says here key points: pick agencies, draw missions, lay out locations, shuffle outcomes, set out decks, etc. Calendar 1956. I don't know, because apparently this company that made this game doesn't really specialize in games. I think that they do more embroidery and cross-stitching and stuff like that. So they're more like a craft company. But not only are the components top-notch and the idea of the game is superb, this is an extremely well-written piece of documentation. When I compare it to companies that make games, like, I'm looking at you, Dan Versen Games, and they write rules that are just basically all over the place. I just wonder how these guys made it. But, you know. The mission cards represent the goals of the game. They come in 3 difficulty levels: easy, medium, and hard. The back of a mission card shows which it is. Separate the mission cards into 3 separate decks by level, then shuffle each deck. For a normal game, draw 4 easy missions and 2 medium missions. Lay them out on the table so everyone can see what the goals are, then put the rest of the missions back in the box. If the players would like a more or less challenging game, here are some suggested sets of missions to draw instead. Again, I can't fault them for this. This is really, for somebody who is trying to get into gaming, this is the perfect gateway game. Of course, then everybody might go, oh my god, modern board games seem to have a strong mathematical outlook, which they don't actually. This is an exception, but you know. So we're going to play an easy game because this is just for me to learn the game and also for demonstration purposes. So I've never even looked at them. So I just draw 5 easy cards. Number 1 is reveal moon location, lunar survey. So what this would have been is we go into, we have to go down to the moon and then we turn over the moon location. If we do this, we gain 4 points. The next one is artificial satellite, working probe capsule in Earth orbit. So we would have to go from Earth with a probe into Earth orbit, and it would give us 2 points. Man in orbit. Okay, so man to Earth, orbit and back. So this means we have to discover flight using people. We have to hire people. We have to put them onto a capsule, so a probe is not enough. And we have to push them back up, but also get them back down, which would include, as far as I can tell, I think this icon actually means landing. You have to be able to land as well. And re-entry is also one of the things that we need to learn how to work it, because otherwise they will just burn up. Landing and re-entry, yes. Because there is a little icon here which is like clouds, or it represents a cloud, and so it looks like a cloud and it represents Earth's atmosphere. So we have to learn how to maneuver through Earth's atmosphere, so re-entry is important, and landing is also important, because otherwise they will land and just crash. So that's something we need to learn. Next up is man to space and back. So that would be enough to just send them into Earth orbit and then back. So where's the difference between man in orbit and man in space? I'm not sure. Or is man in space enough to see suborbital flight happen? That's a good question, because it's only worth 2. But you also have to do re-entry and everything. So I would say that man to space and back is probably suborbital flight. Man in orbit, that's interesting. Okay, because it's also worth less, so it should be easier. And last but by no means least, Mars survey. Reveal Mars location. So we would actually have to go all the way over here into Mars. We have radiation that we need to check. We also have little, and this is something that I haven't mentioned before. We have this radiation symbol. So if you go into the inner planet transfer, you only spend time, so this takes longer, so you need to provide them with rations. But if you go to the outer planets, like Ceres, Mars, Venus flyby, Mercury flyby, you end up with the fact that you also have to deal with solar radiation. And the same goes for going to Mars. You have radiation. Mars orbit has radiation. Mars flyby also has radiation. But also, oh, actually, it's like this. It's like this. So these are the inner planet transfers. So I think I'm missing the outer planet transfers. I'll have to check this one up. Okay, so I'll have to see where this card went. I'm pretty sure I've got it, but you know, I didn't put it out. So if you go to Mars orbit, you face radiation, but you also have this little time symbol. I don't know if you can see this, probably not. It's like an egg timer, and it means that you have to spend time to actually get there. So this simulates the fact that Earth, of course, is a lot further away from Mars than it is from the moon, and you have to reflect this somehow. So you have to add little tokens, and I'm not sure if they came with the original game or if this is something that I just got because well, where are they? Oh, yeah, wait, there's more. You have these little tokens over here. These little egg timer tokens, and you put them down. Oh, and this came with a D8. That's handy. I didn't realize. So you have to represent this. So this is going to take longer, which is also why it is worth 5 points. Now, also the point is that each of these egg timers, as far as I can recall from watching playthroughs, represents 1 year. Now, you only have a couple of years to, well, a couple of decades to complete this, but between ensuring that what you're doing is safe, nobody dies, nobody is going to be affected negatively by your research because it wasn't carried out properly, you know, and the fact that you have monetary constraints because you don't have an unlimited budget, you have to provide a budget to do all of this. It's going to be quite an interesting game because you have to, I guess, risk manage. And we will see if I will be able to overcome my natural fear of sacrificing people to say, well, we're just going to send him to Mars anyway, even though we don't know if our rocket is actually going to be up for it. So that's what's going to happen, hopefully today, and I wish you all a pleasant day until such time as we return to our leaving Earth.